Oh, yes. That cools us down. It makes our drinks so much better, refreshing. And it's
it's delicious.
I know, right? This is a fascinating segment. Trust me, it's not just frozen water.
That's right.
Dan Kohler is here to explain really what goes on other than just frozen water.
Yeah, I mean, I think we take ice for granted a lot, don't we? Like, it's in all of our drinks, and we never really think much about it. But actually, ice is a really interesting chemical compound. And if we want to understand it more, we need to actually look at the building blocks, which is H2O. I mean, and think about ice for a minute. It can be a glacier, or it can be an ice cube. So it really looks so different depending on its environment. And this is what H2O looks like. 1 hydrogen atom and 2 oxygen atoms. Now, when H2O is in its liquid phase, there's almost no space between those molecules, and it's really dense, and they're loose. This is what water looks like. But as you lower the temperature, the bonds between those molecules actually get stiffer and stiffer, and they press each other away until what you've got is an ice crystal. So this is what H2O looks like as it freezes. The molecules actually line up, they push each other away, and you get this beautiful crystal formation. And that's actually what's happening as you freeze.
So in the water, if I was looking at a crystal right now, it would be one of the...
You could see it.
Yeah, you see it inside.
Can I ask you, Dan, why I've never understood.
Go for it, Debbie.
I'm going to say it. I don't know. I hope you all feel the same. Why does ice float? Shouldn't it sink?
All right, it's sort of a strange...
It doesn't make sense.
You think something this heavy and solid should go to the bottom.
That's heavy. That is even heavier.
Believe it or not, when we started out, this block was 300 pounds.
Why does that float?
So as you press each other away, now look about this. This is water. It's very dense. Even though it's liquid, right? The molecules are very close to each other. But when it freezes and they push each other away, there's a lot of space in ice. In the same way that a hot air balloon rises above regular air, because the air molecules are farther away from each other, they are less dense. And ice is less dense than water. The molecules have pushed each other away in order to freeze.
Okay.
That's fascinating.
So now, some of it's clear.
Yes.
Like, that's clear. Why is there, like, the white surface kind of thing?
You can get
even cubes.
I mean, you can get really incredible colors in ice. So sometimes it's cloudy, sometimes it's kind of yucky looking. But actually, I went to Iceland last year with my mother, and I want to roll in a couple of these pictures because you can see, ice can be bright blue. Ice can be gray.
That's not reflective off of something?
No, I mean, the inside of that ice is blue. It's got these blue veins. And what's actually happening there is that these ice crystals begin to form. So right here, we've got one ice crystal. And it's nice because everything is forming in one direction.
Yeah.
But what if another ice crystal begins to form in a different direction? Suddenly you've got competing angles, and that reflects the light completely differently. So you get gray, you get blue, you get white.
Do you know what I always thought? I always thought that if the ice was kind of gray and the icing, I thought it was bad water. I said, this is disgusting. It looks dirty. What's wrong with my freezer?
Like this,
I thought something was wrong with my freezer.
Like these right here.
Yeah, and I thought, and I would smell them. I keep smelling them. Something's wrong. We need baking soda in the freezer.
Now, what's happening here, it's white in the center because all water has some air naturally dissolved in it. And as it freezes in an ice cube tray like this, it's very thin. There's no insulation. It's going to freeze from every direction at once, and that air has no place to escape. So it traps the air right in the center. So this is white in the middle, and you get those cracks because there's a bunch of air bubbles in the middle.
So how do you freeze it to look completely clear like the one behind you?
If you want to get
that was clear this morning.
It really was.
Now
it's starting to get a little murky because the surface is interacting. It's melting and then refreezing and melting and refreezing infinitely.
Oh, okay.
Now, if you want to get a beautiful, clear block of ice to have a snow cone party at home this summer, it couldn't be easier, actually. I've got over here just an igloo cooler filled with water. And the reason we're using this is because we want to control the direction in which your ice is freezing. Like I said, in that ice cube tray, it's freezing from every direction at once. But when we do this and we put it with the lid off in the freezer, it's going to freeze from the top all the way down, like a beautiful clear lake in Minnesota. That's how you get this clear ice. And after,
is that because the cooler is insulated?
The cooler is insulated, so it's going to control the temperature from the top down. And so that air actually gets trapped all the way at the bottom. And you can see, it's really fun, actually. After 2 days, what you have...
Oh my gosh! That's beautiful.
I mean, I'm not joking. You get this beautiful, clear block of ice.
That's a nice block of ice.
And you can see actually at the bottom, this is where that air was trapped. So as the water froze from one end down, it pushed all that air down. You can see there.
That's why there's a hole in there. That was
Exactly. This was all the air that was left in the ice. Now remember, when you're freezing things, you've got to leave room because, like I said, ice floats. As those molecules press each other away, this is why water expands when you freeze it, right? If you fill it all the way to the top, it's going to overflow because those molecules are doing this to each other.
So you don't
They're
freeze
trying to
your
get out.
sodas.
Exactly, because it's totally sealed up.
I see a problem.
Tell me about
I
it.
don't have a glass big enough for that cube.
Well,
So
we'll work on that another time.